Hello everyone, welcome back to the part 2 session of marine refrigeration system. In the earlier part 1 session, I have shared the importance of marine refrigeration system and onto the temperature and heat addition graph. I have shown you the phase change process of the water from solid to liquid and liquid to gas and gas to solid, liquid and liquid to gas back again, and also a simple refrigeration cycle. In this simple refrigeration cycle, I have shown you the flow path of refrigerant from compressor to again back to the compressor and components of a simple refrigeration cycle: compressor, condenser, expansion valve and evaporator. Today in this video, I am going to share you about the actual marine refrigeration system that is used on board ship. Let us correlate this simple refrigeration system with actual marine refrigeration system on board ship. But before proceeding further, let us quickly recap some basic definitions of this system. Saturation temperature. It is the temperature at which the medium undergoes a phase change either from liquid to gas or gas to liquid. Back again onto this graph, I have shown you in the previous video at 100 degrees centigrade, the water exists in both liquid state and also in gaseous state, and the heat that necessary to convert from liquid to gaseous is known as latent heat, and temperature at which the phase change occurs is known as saturation temperature. And now saturation pressure. It is the pressure at which a given liquid and its vapor or given solid and its vapor coexists in equilibrium. That means at this pressure, the medium that can exist either in solid or in liquid or in vapor. Subcooling. It is a process of cooling the liquid refrigerant, or suppose let us say for instance the medium at a uniform pressure to a temperature less than its saturation temperature. Earlier I have shared the saturation temperature. What actually the saturation temperature means. If we start cooling the medium than that temperature, then it refers to the subcooling. Refrigeration. It is a process of removing the heat from a substance under controlled atmospheric conditions, and we need to maintain that temperature. Even the surrounding temperature of that substance is keep on changing. That process is known as refrigeration. Cooling. It is a self-lowering temperature process that can happen instantaneously. In the previous video, I have given an example of hot cup of coffee that which you left in your room and you returned after some time, and if you see the hot cup, it will be in cool condition. That which happened without any extra work done on the coffee. That process is known as cooling. Now quickly recap about the closed loop cycle of refrigeration system. For the closed refrigeration system, the flow of refrigerant starts from the compressor discharge side. The compressed refrigerant flown to the condenser for cooling undergoes a phase change from gaseous to liquid. After the phase change, it is sent to the expansion valve for pressure drop. After the expansion valve, in the pressure drop, the liquid refrigerant exits in mixture of liquid refrigerant plus vapor refrigerant, and this sent to the evaporator where the mixture of liquid refrigerant and the vapor refrigerant that completely undergoes a phase change from this mixture to gaseous state. And after the evaporator work is done, again this sends back to the compressor. And this is the actual marine refrigeration system that which used on board ship. Now let us correlate this system with the basic refrigeration system which discussed earlier. Let us find out the parts: compressor, condenser, expansion valve and evaporator. Now let's trace out the flow of refrigerant starting from the discharge side of the compressor. This is the discharge side of the compressor. The flow of refrigerant is from compressor to condenser, and condenser to the receiver to the master solenoidal valve, and from master solenoidal valve to dryer, and from dryer to siphon glass, and siphon glass to thermostatic switch which is solenoidal valve operated, and after that it is sent to the thermostatic expansion valve. After the pressure drop, this thermostatic expansion valve is liquid refrigerant is sent to the evaporator, and after the evaporator work done, and again it sends back to the compressor suction side. And now let's explore the actual marine refrigeration system starting from the discharge side of the compressor. After the compressor work done on the refrigerant, it raises the saturation temperature and saturation pressure of the refrigerant and sends it to the condenser. The condenser is provided with the seawater inlet and seawater outlet to cool the raised saturation temperature of the refrigerant. In the condenser, the raised saturation temperature of the refrigerant cools and changes the refrigerant phase from gaseous to liquid. After the change of phase, the liquid refrigerant is sent to the receiver. In the receiver, where the liquid refrigerant is collected, that received from the condenser, and send it to the master solenoidal valve. This master solenoidal valve is the valve that which controls the entire plant that used onboard ship. Suppose if we stop giving supply to the master solenoidal valve, let us say this solenoidal valve is in closed condition, then even if the condenser is giving the refrigerant to the receiver and the receiver is delivering to the master solenoid valve, as it is in closed condition, will not be able to receive any refrigerant to the dryer or the siphon glass or to the evaporator and again back to the suction side of the compressor. This master solenoid valve is an important one for this entire refrigeration system. This may be present here or here for individual evaporator rooms. Now, after the master solenoidal valve, this liquid refrigerant is sent to the dryer. This dryer is a very special type of dryer where the excess water that if present in the liquid refrigerant will be extracted out and the liquid refrigerant gets completely dried up without any water traces. Here the question may be arise, what happens if the water might enter into the refrigerant? If the water might enter into the refrigerant, there is a pressure drop that's happening in the thermostatic expansion valve. Due to the pressure drop, the water may get stuck in this thermostatic expansion valve and freeze up. So the flow of refrigerant from the TXV to the evaporator may be stopped completely. This I will explain in the further videos in a better way. Now let us focus on to the actual system. Then after the dryer, the liquid refrigerant is sent back to the siphon glass. And this siphon glass is a very special type of siphon glass where it will be given a color coding. If the refrigerant is present with the moisture content, then the color will changes. If the refrigerant is present in a dry condition, then the color is according to the dry condition. If the to know the quick and possible way whether the refrigerant is having the moisture or not, you can observe the siphon glass for the moisture content. Then from here, the liquid refrigerant is branched to different evaporator rooms. For instance, I am taking the single evaporator room. Let us say it is only the meat room where you will be storing the fresh meat. The siphon glass, it is sent to the solenoidal valve operated thermostatic switch. This thermostatic switch is triggered according to the temperature that evaporator needed. You can observe that the triggering point for this thermostatic switch is inside of the evaporator. That means, suppose let us say if the evaporator temperature is set at 4 degrees centigrade or minus 4 degrees centigrade. When the temperature of the evaporator is increasing, that suppose let us say the temperature of the evaporator is moved from minus 4 to minus 3, then this bulb senses that rise in temperature and sends signal to this thermostatic switch. And this thermostatic switch again sends signal to the solenoidal valve, which open and close according to the signal received. For example, in this case, the raised temperature from minus 4 to minus 3 degrees. Then the thermostatic switch is triggered, and this triggered switch sends a signal to the solenoidal valve, and then solenoidal valve is operated to open condition. Then the liquid refrigerant is flown to the thermostatic expansion valve. This thermostatic expansion valve is a capillary tube diaphragm operated thermostatic expansion valve. There may be different types of thermostatic expansion valve, whether it is of electronically operated thermostatic expansion valve, and this one is a mechanical operated thermostatic expansion valve. This valve is triggered according to the temperature of the evaporator situated outside of the room. You can see here this thermostatic expansion valve capillary is located outside the evaporator room. That means after the evaporator work done, that means the complete phase change of mixture of liquid plus vapor refrigerant. This stage to gaseous stage. That means complete the heat extraction from the evaporator room is done when the refrigerant is changed to gaseous state. That means the refrigerant temperature is increasing. It leads to decrease in the evaporator room temperature. In order to say one temperature is increasing, one temperature is decreasing. That means the refrigerant is extracting the heat from the evaporator room for raising its own temperature. And that temperature is ensured by the capillary bulb which is attached to the tubes outside the evaporator. This bulb is very important bulb, and that which triggers the thermostatic expansion valve. According to the triggering measure, the diaphragm is operated. In the diaphragm, below the diaphragm, the thermostatic expansion valve, a pressure region is created according to the load on the evaporator. For example, if the load on the evaporator is high, the diaphragm will be opening the valve, thermostatic expansion valve, more, causing a high pressure drop, leading the refrigerant to drop the pressure very rigorously to meet up the evaporator load. I will be explaining about the thermostatic expansion valve in a better way in the next videos. And after the thermostatic expansion valve, the mixture of liquid and refrigerant is sent to the evaporator, and this evaporator is consisting of coiled tubes where the refrigerant is flowing inside the tubes. This refrigerant is extracting the heat from the evaporator room and raising the refrigerant temperature and leading to the decrease in the room temperature. And after this work done, the evaporator work done, this gaseous refrigerant is sent to the compressor suction side. I think now we have understood the actual flow of the refrigerant in the actual marine refrigeration system. This ends the part 2 video of marine refrigeration system. Still any more doubts, do comment in the comment section below, and if you haven't subscribed to the channel, subscribe to the channel and stay tuned for more updates. Thank you.